Okay, our next section 11.4 is circumference and arc length 60 and 61. Make sure that's in your table of contents. And here we go, page 60. Circumference and arc length 11.4. We have theorem 11.8, circumference of area. Here is your formula. Make sure you know them. That for this particular setup, you have 2 pi r, where r is the radius, or you could do d times pi, where d is the diameter. And then you have a more important formula you really got to know is for arc length. I'm going to be using this first one over and over and over and over and over so you can see the proportion that's being created. But arc length is actually how long this arc actually is. It's not the degree measure anymore. It's actually taking like a tape measure and walking along the edge of that circle and finding out how long it is. If I take a piece of string and line it on there, I can measure how long that string is. I want to know actually how many inches it is, not degrees. So here's our formula that we're going to be using to find the arc length. Alright, on example 1 we have 4 parts here to show you what it's referencing for circumference and radius and exact radius and circumference. On A, it says circumference of the circle with radius 11 meters. Well, my radius, so that means I'm pulling in C equals 2 pi r. That's 2 pi times 11, which is 22 pi's. And that, make sure you use your pi button. Gives you 69.1 meters is your circumference for that problem. If I want to find the radius at the circumference of 18, that means I'm plugging it in for the C. I'm going to divide by 2 pi to find my radius, 18 divided by, and realize if I do it in this fashion, I have to put the bottom in parentheses to get my answer of 2.9 is my radius. And that is yards for the radius. On part C, they have this new word here that says exact radius is what we're looking for. So I'm going to set it up kind of similar to the same. I have 74 equals 2 pi r. I'm going to divide by 2 pi. But this is where things change, because only thing I'm going to do is divide 74 by 2 and end up with 37 over pi. And I'm going to leave it in that fashion. This is the exact radius, 37 divided by pi. On D, exact diameter, if I'm looking at the diameter formula, that's d times pi. So I have 58 is equal to d pi. That means I'm just dividing by pi. And on this, I can't do anything else to it. That means d is equal to 58 divided by pi. Exact items means that you do not actually punch into the calculator what pi is and use it. You leave that as part of your answer. Pi is in your answer. Okay. Example 2 says, okay, the dimensions of the skateboard wheel shown at the right are in millimeters to the nearest meter. How far does the wheel travel when it takes 37 revolutions? So this one is dealing with meters and millimeters. And if I'm looking at this, I'm looking at the circumference of my particular shape. I want to know how many times it's revolving around. And if I notice from one edge to the other, it appears to be 20 millimeters, which I need to convert from millimeters to meters so that I'm in the correct units. And to do so, I go by 1,000, and let me get that calculation just a second. Okay, so here we go. 20 divided by 1,000 gives me that this radius that I'm going to be using in my calculations is 0.02. And I want to find the circumference. So that's 2 times pi times 0.02. Okay, that tells me my circumference is about 1, 2, 6. Give me some numbers that I'm dealing with, meters. And then it tells me another important number, that it is going to go around revolutions 35 times. So I'm going to take that value and now multiply it times 35. And then that distance that I'm looking at appears to be 4.4 meters is how far this wheel actually travels for my final answer. Okay. On the back side I have example 3. I have 2 problems here. So the first one says I want to find the measure of the arc AB, and realize it's not degrees, this is actually how long that arc actually is. So this is where I'm going to create my proportion. I have the angle degree of 145, and I'm going to place that over the entire circle that happens to be 360, equals, I'm looking for that arc measure, so I'm going to make that my x. And then on the bottom I need the circumference, which was 2 pi times the radius, which the radius it tells me is 14.2. Alright, I'm going to cross multiply, and I come out with 145x equals, and now when I multiply the other direction, I just put it all in my calculator. I end up with 129.37.0786. I'm going to divide by 145. Oh shoot. Divided by 145. And that tells me that that arc measures 89.2 inches when I divided it. And that's the length of AB, how long it is, not degree, but how long it is. Alright, on the second part here, I want to find the radius, how long the radius actually is on this arc. For this setup, I have that the arc measure is 14.2. I don't have the circumference, so that's where I'm going to put the circumference formula. Equals, and I have 132 out of the entire circle, that is 360. So I'm going to cross multiply again. 14.2 times 360 gives me 5,112, and then multiply the other direction. That gives me 829.380 R's. And I want to divide by that number. Now make sure you're keeping this all in your calculator so that you're not rounding too early. So make sure that you're pulling it back and using it. So I can see that my radius on this problem is 6.2 inches. If you're rounding too early in your problem, this answer will be skewed. So be careful. It's actually best not to use pi until you get to the end. In other words, you would have 132 times 2. Right here, you'd actually have 264 pi R's, and then you would divide this by 264 pi's. And that would actually give you your true answer, which I believe we're safe on this. Oops, remember to put that in parentheses. Unless you actually make it a stacked fraction. If you make it a stacked fraction in your calculator, then there's not a problem. In there you can see we come out with almost the exact same problem because I was carrying out decimals on my problem. Okay, example 4. A conveyor belt for luggage at an airport is shown at the right. So here's the conveyor belt with little luggage on it. The outer part of the belt forms a 180-degree arc, that's a degree arc, at each end. For each arc, the radius is 8 feet. Okay, so it has 8 feet. Okay, from center all the way to edge is 8 feet. Approximate the distance around the belt for a coin on the outer portion. So we want to go around the outside edge of our shape. And I don't believe this was necessary at all. So I'm going to go ahead and mark that out. I don't think that's supposed to be there. Okay, so if I want to find the circumference, and since it's going along the outside, I'm going to use the 8 feet, not the 4. The 4 is if something is going along on the inside track, which we're not using that, so I'm going to ignore the 4 on that problem. So I'm going to find the circumference using 8 feet. Well, that would be 16 pi to be exact, which is approximately 50.3 for my circumference in feet. And then I have the 20 feet on the side, that is on both sides 20 feet. So the linear ones on the sides, 20 plus 20 gives you 40. So I'm going to take the 50.3, oops, plus the 40, end up with 90.3 feet is how much a coin on the outside of that belt is rotating around the conveyor belt. Okay, independent practice number 1. It says find the circumference of a circle with a diameter of 23. So since we're dealing with the diameter, that means we can use the pi d formula. So that means that's pi times 23, so your circumference is 72.3 inches. Okay. Number 2, a skateboard wheel has a diameter of 56 millimeters. So here we have the wheel again, and all the way across is 56 millimeters. It says how many revolutions does the wheel make when traveling 3 meters? Alright, I need to find my radius. So I'm going to take half of 56, and that means my radius is 28. Actually, I didn't have to do that. I forgot about my formula, pi d. So I can actually just calculate 56 pi as being my circumference. And here I can see that my circumference is 175.93. I'm going to give myself 2 decimals there. And this is dealing with millimeters because I didn't change it to meters. So I actually need to back up one more time. I'm jumping the gun here. I need to convert this from millimeters to meters. So I'm going to take 56 and divide it by 1,000. And that should give me 0.056 meters. So on my formula here, I'm going to use my whiteout and back up a little bit. So I'm actually going to use 0.056 pi. And see that this is 0.1759 roughly meters for 1 revolution around the wheel. Now it wants it to travel 3 meters. So it wants to know how many revolutions will it take to go 3 meters. So I'm going to take my 3 meters and I'm going to divide it by how much it is for just 1 time around and see how many times it'll go into it. So I'm going to take 3 divided by, and I'm actually going to pull it back to the original number and see that it takes roughly 17 revolutions to go 3 meters with that size of wheels. Okay, independent practice 3 of 4 has 2 parts to it. It says we're trying to find the arc length of AB. If my arc length I know is 97, I always put it over the entire circle, so 97 over 360 equals the arc length that I'm looking for. I don't know it, so I'm going to make that my x over the circumference, which is 2 pi times 4, which is my radius. So I'm going to cross multiply. That gives me 360 x's equals, I'm going to put 760, I'm sorry, 776 pi's. I'm not going to multiply pi just yet. And then I'm going to divide it by 360 so I can put it all in my calculator at once. So I'm going to type in 776 pi divided by 360. And when I put it all in, I get 6.77, which is basically 6.8 feet is the arc measure of AB. How long it is, actually. Not arc measure, arc length. Alright, on the second part it says once we find the circumference of this particular circle. Here they tell me the arc length is 3.44. I need to place it over the circumference formula because that's what I'm actually looking for. And actually, since I'm looking for the circumference, I don't even need this formula. I can just actually put a C on that one. Equals, and now I need my degree measure, which is 60 over 360. I need to cross multiply. It gives me 60 C's is equal to 1238.4, and then I'm going to divide this by 60, and it tells you your circumference is 20.64 centimeters. And now the last independent practice. Here we have that conveyor belt again. It says the inner portion of the belt also has a 180-degree arc at each end. The radius at each arc is now 4 feet. That's where I'm using this bottom one now. That the radius I'm looking at is 4 feet, so I'm not using the 8 feet on this problem. Find the distance around the belt for a coin on the inner portion, round to the nearest foot. Oh, round to the nearest foot. Did we do that on the last one? Oh, round to the nearest foot. So this would have to round to 50 feet. Oh, no. Right here. This would round to 90 feet. I just realized that. 90 feet is your answer. Alright, so here we go. On this one, once again, I'm going to find my circumference. But this time the radius is 4 feet. That means this is 8 pi's for my radius. And then the 20 distance, 20 feet, is on both sides still, so that means I'm still adding 40 to it. So that means I have 8 pi plus 40 represents, what does that represent? I guess that's my distance traveled. So 8 pi plus 8 pi plus 40 gives me 65.13 feet is how much it travels. So nearest foot means this is just 65 feet for the conveyor belt on the inside. Alright, if you get these correct, give yourself a smiley face. See you tomorrow.